over relating quadratic forms. So you very deftly pulled the vertex form out here, okay? And I'm going to write it here because I know that when you pulled it out, you used some pretty neat methods to solve it. I'm just going to relate these forms here because I know one of the things that you did to solve this is that you remembered that each of the forms had the a value in common, which was excellent because it allowed you to use a method I hadn't seen before. I really liked it. Bx, sorry, I'm just a little tedious this part, but it's important because we want to draw on the form. And what we're attempting to do is we're trying to get into factor form, okay? And we're really used to seeing factor form written like this. A on the outside, x minus r, and x minus s. I'll put them in green, I guess, this time, okay? I'm going to jump back a page. This thing you've done here is excellent. I'm going to jump x plus 1, 4x plus 3. So you went through the factoring process. You went from standard form, you used this form, and you went through factoring. And you got to this point. You said f at x is equal to x plus 1 and 4x plus 3. And when we talk about factor form, many of the times this would be acceptable. They go, yeah, this is great, this is done. But we run into a small issue of our own is that we go, well, where's my a in this question, right? I have a set of brackets and I have another set of brackets. So that looks great, and I'm going to assume is a1. That's what I would assume if I don't see it. But we know because you went into vertex form and standard form, you knew a is 4. So you're sitting here going, I can't get these ideas together. What's the problem with this? And the problem with this is we don't always talk about when we go into factor form is that in factor form here, we're talking about when the x value, so the coefficient in front of both of the x's, is 1. The coefficient here is 1, but the coefficient here isn't. How can I turn this coefficient into 1, Nathan? What could I do to do that?
You could multiply.
Okay, what would I multiply by?
Oh, wait, no, I don't know.
Yeah, and the one issue is if we multiply, we'd have to multiply the other side of the equation too, right? We'd have to keep it balanced. The step before this, I'm going to jump back to your previous page. I know we didn't quite show it here. But you did this. You did common factoring, okay? You did some common factoring, and we're left with this. Let's continue that. Let's common factor out the value of 4, okay? What's going to be awkward is this part here. We're looking at it going, oh, that's not a whole number. That's okay. In math, I know we always work with whole numbers in demonstrations, but there are far more non-whole numbers than there technically are whole numbers. Technically, there's infinite amount of both, but there's some infinities that are larger. Don't worry, it's not too important for what we're doing. But this is very, very common. It's common not to have a whole number in math. So we have to try to wrap our heads around that because we're so used to working with really nice numbers that we have to be okay with sometimes things aren't nice numbers. So we have x plus 1, and we're going to common factor out the number 4. We'll put it in its own bracket, and we'll be left with x. How can we represent this?
Represent which one?
3 over 4, or 3 divided by 4. How can I represent that?
3 over 4?
Yeah. I mean, we can convert it, right? We know we can say
0.75?
Yeah, I could say that. Don't be afraid, and I know we sometimes shy away from it. You can represent it as a fraction. It technically means the exact same thing. Whatever you're more comfortable with. If you rather write the decimal value into this space here, go for it. I actually prefer working with fractions just because if we go farther, I find fractions easier to work with because it's still kind of whole numbers. But what's really important, what we were trying to get at is we've now found our missing a value. There it is. Once we've made the coefficient in each of the brackets 1, we found our a value. So now we can come to peace in our mind with, hey, here's that a value I was thinking, plus 1.
Yeah.
And now here's the trick. This is what I want to ask you, okay? A lot of the times when we're in this type of factor form, so I'm going to refer back to, I'll put a green arrow, this form here. When we get to this point, if I asked you, hey, what are my x-intercepts? Do you know what you would do from here? Do you recall what you would do to find x-intercepts from these two brackets?
Yeah.
What would you do?
x1 plus xy over, x1 plus x2 over 2 is equal to axis of symmetry.
Okay, that will give us like an x value of the vertex. But what if I'm looking for x-intercept? So I'm looking for, I'll give you a little graph here, where it intersects the x-axis. So say we have a parabola. Actually, this one happens to open upwards.
It's -1 and -3/4.
Ah, very good. You're able to see that from here. Excellent. So x is -1 and x is equal to -3/4. I want you to look at this. That's exactly what we did. Okay? It's an even more obvious form once you common factor out that value. Okay? So now you've got what your answers here. So you've moved between all of the forms and you've kind of related them all. Okay? So anytime you're trying to pull that idea together, like, hey, where's my missing A? And it'll be common in factor form for it to look like it's missing. Don't forget to common factor out to make sure your coefficients are both 1 in factor form. And not only does it give us the 1, it very easily gives you the x-intercepts. Okay?